Hello everyone, in this tutorial I will discuss linear regression using Python. So we will build a linear regression model with the help of Python, and this is the data. This is my data set. You can see the car data. You can see different columns: car name, year, what is the present price of the car, kilometers driven, fuel type, seller type, transmission type, and seller price. So we will use this dataset for building a model, and then we will predict a selling price of the car by providing some of the data. So we will discuss it in detail. So first of all, let's load this data onto the Google Colab. So go to the files, and here just just upload this data, and copy the path. And when you copy the path, after copying, you can paste it in the read underscore csv function. So first of all, let's check whether the data has been uploaded and we are able to read the csv file or not. So I am importing the pandas and numpy and pyplot, and then I will upload the data, and with the help of read csv I am creating a data frame. So data frame name is car, and dot head 10, it means I am printing the first 10 rows of my data. So you can see the data has been loaded successfully, and I am able to print the data frame, and I am able to print the first 10 rows of my data, you can see. And then df underscore car dot shape, with the help of shape I will be able to find the number of rows and number of columns. So there are 301 rows in my data set and 8 columns in my data set. You can count, these are the 8 columns in my data set, and there are 301 rows. So dot info function is used to find the more detailed information of every column. For example, you can see 0, a column name is a car name, 1 is year, 2 is present price, and there these are the columns, and there are all the non-null values. Non-null count are 301 values are non-null. There is not a null value in my data set, and you can even see the data type of all the columns. And df underscore car dot is na dot sum is used to find whether there is any null value in my dataset or not. So when I click run this cell, you can see the columns, and you can see the number of null values. So in my data there is no null value. I have removed all the you can see missing values from my dataset. So you can see car name column has 0 null value, and similarly for all the other columns you can see the number of null values are 0. When I see my data, you can see there is one column year, and I will convert this column into a age of the car. So how old is my car? So what I will do, I will create a new column df underscore car age, and 2023 is the current year, and I will subtract the df underscore car year. So I will subtract this value year from my data, and I will subtract each value from 2023, and then I will drop this column here, and I have added one column age, and I have dropped one column year, and then I am printing the first 6 rows of my data frame. And you can see there is no year column now, and you can see the age column. So let me show you the data. You can see, so for the first row, car name is Ritz and year is 2014, and I have dropped this year column, and I have created a new column age by subtracting the value from 2023. So 2023 minus its value is 2014, so I am getting 9 here in the age. Now we will plot a bar plot for each of the categorical feature, and you can see there are 3 type of categorical features. One is the fuel type, another one is the seller type, and another one is the transmission. I am not considering this as a feature because it's just a car name. So fuel type, seller type, and transmission are the categorical features. Now I will create a bar plot for each of the categorical feature count. So it's very simple. First of all, I am creating a categorical features, you can see, and then I am running a for loop for column in categorical features. First of all, I am counting the values. So very simple, I am passing the column in the data frame and dot value counts, and then I am creating a figure. So plot dot figure size is 5, 5, and I am getting a axis. So figure dot gca means get current axis. So I have explained each and everything in my previous videos. You can see in the playlist how what do you mean by this GCA, how to create a bar plot, etc. And then I am using the counts. So first of all, I was extracting the counts value here, and then with the help of counts I am creating a plot dot bar on the axis, and color of the bar is steel blue, and set title is the column name. For example, column name is fuel type. So first chart will be fuel type counts. Similarly, when the column name is seller type, the title will be seller type counts. And on the x label, x-axis, I am printing column. So column is fuel type, and on the y label I am printing frequency. So let me run this code. You will be able to understand. So you can see, first chart is fuel type counts, because first categorical feature is fuel type, and title is fuel type counts. And on the x-axis you can see the uh, fuel type, because on the x-axis I am getting the column, okay, and on the y-axis I am getting the frequency. So for each of the categorical feature like fuel type, seller type, and transmission, I am creating a bar plot so that I can understand my data. So you can see from the data that CNG cars are very less than that diesel cars, and then the petrol cars. Similarly, seller types. So if the seller is the dealer, you can see the frequency, and if the seller is individual, you can see the frequency. And similarly for transmission count, the automatic cars are less and manual cars are more. So by creating a bar plot, you can better analyze your data. And now I will create graphs for the numerical features. So I am creating a numerical features. I am first of all getting the numerical feature, then I am creating a box plot for each of the numeric features. So various numeric features you can see from the dataset are, let's say, you can see kilometer driven, selling price, present price. These are the numerical features. So and age column also is my numerical feature. So first of all, I am creating a list of numerical feature, and then for each of the column in the numerical feature I am creating a figure, and on the every axis I am creating a box plot. So it's very simple. So let's run this cell, and you can see the box plot for each of the numerical feature. So selling price, similarly you can see the box plot for the present price, similarly for the kilometers driven, and similarly for the age. And now I am creating a histogram for each of the numeric features. So different numeric feature you can see present price, kilometer driven, age, and for each of the numeric feature I am creating a histogram, and also I am drawing the mean and median on the histogram. For mean I am using a line color of magenta, and for median I am using line color of cyan. My main focus on in this video will be on the regression, and these parts I have already explained in my previous lecture. So just run this code to see different histograms for each of the numeric features you can see. So you can even see the mean and median on the each of the chart. So I have three chart: present price, kilometer driven, and age. Present price, kilometer driven, and age, and on each of the chart you can see the mean and the median on each of the chart. So next I am again printing the head. So I'm printing the first 5 rows, and you can see for the regression purpose this column is not important, car name is not important, these all are other columns are important. So what I am doing, I am dropping the label car name from my data frame. So let's drop. So for that I am using frame name dot drop and label name, and then I am printing the head to check whether this column has been dropped. And you can see there is no label car name, there is no column car name in my data frame. So there are some, you can see there are some numeric values, and there are some categorical value, for example fuel type, seller type, transmission. So what I will do, I will convert this categorical values into numerical values. For that what I will do, I will simply use data frame equals to pd pandas dot get dummies, and I will pass the data frame. And this line, this statement will convert the categorical values into the numerical values. So when I use this, and let me first of all run this cell, and you can see there are no categorical values in my data frame now. And what is the logic? So you can see these this column, these columns, fuel type, seller type, these are categorical columns, and I have converted these categorical columns into the numeric columns. So you can see, so actually fuel type, I have three type of fuel type: petrol, diesel and CNG. So it has created three columns for that: fuel type CNG, fuel type diesel and fuel type petrol. And similarly seller type has a dealer and individual. So it has, so first of all let me show you. Okay, you can see the seller type dealer and seller type individual. And similarly for the transmission, it has created two columns: transmission automatically and transmission manual. So it has been done with only one statement, that is the pd dot get underscore dummies, and here I am passing the data frame. So it's very simple. Next what I will do, I will separate the features and labels. So here in y I am getting the selling price, and in the x I am dropping the selling price. So you can see the features are in the x and the labels are in the y. So labels are actually what I want to predict from my model. So I want to predict the selling price. For that, so that I have created a separate label for selling price, and all other columns are the labels, sorry, all other columns are the features. So let me run this code. So you can see the features are these value: price, kilometer driven, all the values are the, you can see the features, and this is the label. So label is what I want to predict, and features are the values with the help of which I will give to my model to learn. So these are the features, and this is the value that I want to predict, that is the selling price. Very simple. And now this is the main part. So this is the main part that I will split the data into training set and test sets. This was my data set, and now I will split this data into training set and test set. So I will split 70% training set and 30% test set. For that I will use train underscore test underscore split, and I will first of all import it from the sklearn library. So sklearn dot model underscore selection, I will import train test split. So what I will do, I will just pass these values. So x comma y, x is the feature, y is the label. Test size is equals to 0.30, means the my data set will be divided into two parts, and 30% will be the test set and 70% remaining 70% will be the training set. And the random state is 0. Random state is used to seed the random number generator, so ensuring that split is reproducible. For example, if you have set the random state equals to 0, you can obtain the same train test split every time you run the code. So every time I run the code, I will get same uh, train test split. And if you want every time these train test split will have different values, you will have to pass a different value here. Random state I am passing 0. It means every time I run this cell, train and test split will be the same. So then I am printing it. So I am printing how many training set rows and how many test set rows I have. So just run this cell. You can see training set has 210 rows and test set has 91 rows. And I am also printing the shape of every. So I have the features for training, features for testing, labels for training and labels for testing. And I am getting the shape of each of the feature and each of the label, you can see. After splitting my dataset into training set and test set, what I will do, I will train my model using the training set. So for that, what I will do is very simple. First of all, I will import the model. So I will use the linear regression model. So first of all, import linear regression model from the sklearn library, and then I will train the models. For training, I will use linear regression fit function. So fit the linear regression model on the training set. Very simple. So I will create a model, and then I will fit this model with the help of linear regression. So very simple, linear regression dot fit x underscore train on y underscore train. So I have the features for training and label for training. So I am passing it to my model so that it can fit and it can be trained. So just run this cell. So I have trained the model. Then I will use this model to predict the values. So what I will do, I will import numpy as np, and I will do, I will create a, I will first of all with the help of model I will predict. So what I will predict, I will pass the x underscore test value, and then I will predict what will. So I am passing some features. I am passing the feature set, and then I am trying to predict the label. So I am what I am doing. I am using model to predict, and I am passing x underscore test. So it will print the predicted labels and actual labels, you can see. So just run this. So predicted labels are these values and actual labels are, you can see, these values. So but I am not able to understand what is the actual predicted label and actual labels. So for better understand it, I will create a scatter plot. So I will create plot.scatter, and here I will pass the testing and predictions. So on the x level I have the actual labels, and on the y axis I have the predicted labels, and plot title is the selling price predictions, and then I will plot the it, and you can see my plot, and the color is magenta, you can see. But the problem is that this you can see plot, this graph is not fit properly. So for fitting it properly, what I will do, I will use polyfit. So first of all, I am creating a scatter graph from the y test and prediction. On the x level actual price, and on the y axis predicted price, and plot title is selling price prediction. And then I will use numpy polyfit function that is used to fit the data within a polynomial function. Actually my data here in my previous graph is not fit in the polynomial function. So now I will use a polyfit function to fit the data within a polynomial function. For that, what I will do, I will use polyfit function. So I will pass y test and predictions, and now I am storing it in z. So z contains the slope and intercept of for the best fit line, and then I am passing the jet into the poly 1D. So poly 1D is used to create a one-dimensional polynomial object from the coefficients obtained from the poly fit. So now this polynomial represents the best fit line. So what I will do, I will simply pass y test, and so you can see when I run this cell, now my data has been fit polynomially. So you can see all the price, you can see all the selling price predictions, and this is my uh, line, that is best fit line. So with the help of polyfit function, I am actually obtaining the slope and intercept of the best fit line. So slope and intercept I am obtaining from it, and then I am creating a graph, I am drawing a plot. So very simple. So next, what I want to find, I want to find the mean square error and the R2 score. So these are actually used how best my model is fit. So I am first of all, so I am importing mean squared error and R2 score. So mean square error is the square difference between the predicted and actual values. So you can see the predicted values and the actual values on my graph. So these are the actual values and you can see the predicted values. So I first of all I will find the mean square error, and then I will print it, and then I will also use a root mean square error. So root mean square error I will find with the help of mean square error. So it is the square root of the mean square error. The smaller the value, the better the model is. So then I am also print the R2 score. So it is also a relative metric for finding the whether a model is best fit or not. So I will print all the values. So you can see the mean square error, root mean square error, and the R2 score of my model. Now I have trained my model, and now I will use this model to predict a selling price of the my of some new values. So first of all, I am printing the values that I used while training the model. So these are the values which I used while training the model. So now I will create a new data frame, and I will pass some new values for each of the columns. So you can see present price, kilometer driven, age, and every value I will pass. So present price, let's say 8, and kilometer driven is 10 lakh, and age is let's say 3. Fuel type is petrol. So if the fuel type is petrol, then I will pass fuel type CNG to 0 and fuel type diesel to 0, and seller type is dealer, so that's why I am passing seller type individual to 0, and transmission automatic is 0, and transmission manual I am passing 1, and I am creating a data frame, and then I will pass this data frame in the model predict function to predict the price of the this new data. So just to run this cell, and boom, you can see that my model is correctly predicting the value. So if this is the data, if the suppose car present price is this and kilometer driven is this, and I want to predict the selling price of new car that I have the data, so I can simply pass it in the model predict function to predict the price of that car. So this price is in the lakhs. Very simple, I can change any value. For example, let's say the present price is, let's say 6, and kilometer driven, let's say 50,000, and the age is let's say 2, and fuel type is let's say diesel, and I can change these values, and seller type let's say is individual. So this is my data, and I want to predict the selling price of this data. So simply pass this data frame in the model predict function, run this, and you can see present price is this one, and I can sell the car at this rate. So let's change this value, let's say it's 10, and age is let's say 8, And if I run this, you can see the model has predicted the selling price this value. So it's very simple. So my regression model is working perfectly fine now.